Hi, it's Moser with a limiting and excess reactant example problem if you still feel like you haven't quite gotten the hang of it and you want to see a couple more. We're going to start off with this reaction. This is of course a thermite reaction where we're taking powdered iron oxide, mixing it with powdered aluminum, heating the whole thing up using a magnesium fuse, and we get out of that aluminum oxide and pure molten iron. Pretty cool stuff. Well, what if we're given 250 grams of iron oxide, iron 1 oxide, and 75 grams of aluminum? Which reactant is limiting? Which reactant is excess? And how much of that excess reactant is left over? Well, to find out, of course, we're going to set up a factor label that compares the two reactants. We can start with either one. I'll go ahead and start with the iron 1 oxide because it's the first one listed. I always put my given in the first box of any factor label, and in this case, since I'm starting with the iron 1 oxide, I'm going to use as my given the amount of iron 1 oxide that the problem states I was given to run this reaction. Okay, well, what do I want to end up in again? Oh yeah, I want to end up in grams of my other reactant. So I'm headed for grams of aluminum. By doing this, I'll be able to determine whether that 250 grams of iron 1 oxide will be able to react all of the 750 grams of aluminum, or if it will have some excess aluminum left. All right. I know that my units in chemical need to be the same in the next box, so I've put grams of iron 1 oxide down there so that we'll cancel. And then I know that I want to go into moles of iron 1 oxide, so I've put moles of iron 1 oxide above it. Now, again, I know units in chemical have to be the same here so that they'll cancel. So I have moles of iron 1 oxide. And I know I want to end up in grams of aluminum, so I'm going to have to go through moles of aluminum. This is where I'll put my mole ratio. That's right, the heart of the problem. My final box will involve my conversion from moles of aluminum to grams of aluminum. So my units in chemical down here must cancel, and my final step will be converting it into grams of aluminum. Now, where do I get those numbers? Well, before I can do anything stupid, I'm going to toss a 1 into each of these, because I know that unless the moles are a given or part of a mole ratio, the only thing that can go in front of them is 1. I'll go ahead and get my molar masses. So I have 71.85 grams of iron 1 oxide in every 1 mole of iron 1 oxide. That's shown here. And 26.98 grams of aluminum in every 1 mole of aluminum, shown there. Now, where do I get my mole ratio? That's right, from the coefficients in the problems, in the equation rather. So I have 3 moles of iron 1 oxide for every 2 moles of aluminum. Now I'm ready to go ahead and do my math. I get a raw answer of 62.5840872. It goes on and on. Grams of aluminum. Now that I have that number, what do I do with it? Well, I'm going to get out my sentence sheet. Aha, you remember that sentence sheet? Hopefully you picked up a paper copy in the folder. So I'm going to write a sentence using number 1, my given, number 2, the answer that I got, and number 3, the amount of aluminum that I was given. Let's see how that looks. 250 grams of iron 1 oxide could react 62.6 grams of aluminum. However, we were given 75 grams of aluminum. Therefore, we will have 75 minus 62.6, or 12.4 grams of aluminum left over. So we got lucky in this case because if you happen to do the reagent first that allows you to find your excess immediately, you know by default that the other one is your limiting. You don't have to do a second factor label, but you don't always get that lucky. Okay, so remember, start with one reactant, finish with another, use your sentence to compare them, and that's really about it. Okay, so given, let's try one more. Given 2 moles of sodium hydrogen carbonate and 1 mole of calcium chloride, you produce 2 moles of sodium chloride, a mole of calcium carbonate, 1 mole of CO2, and 1 mole of H2O. Now, if you're given 565 grams of each reactant, which one's limiting? Which one's in excess? And how much of the excess remains? Of course, you already know you're going to be comparing your two reactants, and we're not worried about the products at all at the moment. I've gone ahead and gotten the molar masses figured, so I'll put those right there, and I'm going to go ahead and set up my factor label. Again, it doesn't matter which one I start with. I can start with either, and if I get lucky, I only have to do one. So I'm going to go ahead and start with my sodium hydrogen carbonate just because it's the first one listed. So I've gone ahead and put my given in the first box, and I know that my units in chemical have to be the same down here to cancel. And I know that since I'm starting out in grams, I'll have to go to moles so that I can use a mole ratio. Now, where am I going with this? Yes, I'm going to mass of calcium chloride. So I further know that once I'm into moles of sodium hydrogen carbonate, I'll have to go through a mole ratio and then convert to mass of calcium chloride. Okay, if my units in chemical are going to be the same here, that means that I'll put my moles of sodium hydrogen carbonate on the bottom, and that allows me to do moles of calcium chloride on the top to get my mole ratio. My last box will be my conversion from moles of calcium chloride to grams of calcium chloride. And I'll have to make the units match here. Alright, now to fill some numbers in. So obviously I know that the only number that can go in front of moles, unless it's a given or a mole ratio, is 1. And I'm going to put the molar mass of sodium hydrogen carbonate in here. There are 84.01 grams of sodium hydrogen carbonate in 1 mole of the stuff. My mole ratios, the heart of the problem, are going to come from the coefficients in my problem. And I see that I have 2 moles of sodium bicarbonate or hydrogen carbonate for every 1 mole of calcium chloride. Then I'll put in my molar mass of calcium chloride, and I know that 1 mole of calcium chloride is equal to 110.98 grams of calcium chloride. Let's see what I get. Aha! 373.19, etc. grams of calcium chloride. Well, let's write a sentence. It looks like we got lucky one more time. When we write our sentence, we see this. 565 grams of sodium hydrogen carbonate could react 373.19 grams of calcium chloride. However, we have 565 grams of calcium chloride. Therefore, we'll have 3 minus 2, 191.8 grams of calcium chloride left over. So, we have found our limiting, we have found our excess, and we would write our final answer like this. Sodium hydrogen carbonate is limiting, CaCl2, calcium chloride, is excess, and 192 grams of calcium chloride remains. That's really it. Remember, compare your reactants, write your sentences, practice. That's it.